Consider a circle of radius 1. Let's pop a point on that circle and join that point by a straight line to the origin. This defines the angle between the positive x-axis and that straight line. Now let's consider the tangent to that circle at that point, that is, the straight line that just touches the circle at that point. And rather than consider the entirety of that line, let's just consider the segment from where the point is on the circle to where that straight line touches the x-axis. So that's the segment shown in green. What we mean by the tangent of that angle is the length of that green line. So if we let the point move around the circle, you can see how the tangent of the angle varies with the angle. Now there is a slightly awkward extra part of this definition to do with whether we should regard that length as positive or negative, and we're not going to get into the details of that here. The only reason we introduce this is so that you're aware of the reason why this function is called the tangent. It has something to do with a tangent to the circle. A more useful definition will be that the tangent of that angle is the gradient of that straight line from the origin to the point on the circle. So if we let our angle go down to 0 and then consider what happens as that angle increases, we will have an increasing positive tangent from 0 to 90. Between 90 and 180 we'll have a negative tangent which is going down to 0, and then another positive tangent from 180 to 270. From 270 to 360 we again have a negative tangent. Here we have that straight line from the origin to our point illustrated as the hypotenuse of a right-angled triangle. We'll remove the restriction that that hypotenuse has to have a length of 1. So let's consider a triangle with a slightly larger hypotenuse, and of course the other two sides will be scaled up by the same amount. Well, the gradient of that line will still be exactly the same, even if the triangle now has a hypotenuse of any length. And the way we would calculate that gradient would be to measure the increase in the y-coordinates divided by the increase in the x-coordinates. But the increase in the y-coordinates is the length of the side opposite the angle, the side we've called O. And the change in the x-coordinates is the length of the side adjacent to that angle, the side we've called A. So therefore, we can define the tangent of that angle x to be the length of the opposite side of the triangle divided by the length of the adjacent side. And we therefore recover the definition which is most usually used. However, it's important to realize that this definition only really works if your angle x is greater than 0 degrees and less than 90 degrees, whereas our definition of it being the gradient of that line in the circle will work for any angle at all.